Flack math! Give me some math and I'll give you some flack. Flack math!
So vectors. So a vector is a quantity that has both magnitude and direction. They said it wrong though. They said magnitude first. You're supposed to say magnitude second.
Just because it's in a movie doesn't mean that's how it's saying.
Well, movies are powerful. Movies change the way you think. So, this is wrong.
Your imagination is what changes.
Yeah, but popular opinion changes things, changes policy, changes a lot of things, whether you like it or not. The direction of a vector is basically the orientation of the vector, like the slope usually, which is determined by the angle the vector makes with a horizontal line. Okay, in contrast to vectors, a quantity that consists only of magnitude is just called a scalar. Okay, so a scalar is only magnitude. Okay, so remember like the absolute value of like -3. Well, that the scalar, it's just, it has a magnitude of 3. It doesn't matter. Or like the length of a side. We don't care about the direction. How far is it? Well, I guess you kind of care about the direction in some cases. But anyway, vectors are named by italicize a lowercase letter with the vector symbol. Okay, so for example, if this was a vector and it looks like a ray, but this is R, and instead of a ray symbol, it's just like a half of an arrowhead. Okay, so see how it's like an arrow, but only the top part of the arrow, the pointy part. So, and unlike a ray, see how a ray goes on forever? But this arrow is not saying it goes on forever. It's saying that it's going in this direction. So it's kind of confusing, but that vector has a beginning point and it has what we call a terminal point. We don't call it an end point because it looks like it goes on forever, but we call it a terminal point. Okay, so here's the initial point. And this is the terminal point. Okay, so I'm going to share my screen and we're going to look at just some examples here. So these are just a little bit difficult to draw, so I'm not going to draw them. Sorry, I should have had this prepared. Please forgive me. Your internet connection is slow. Tell me what I okay, look at that. Right to it. Okay, so here's some examples of vectors. I share with you at home. What happened? Okay, so can you guys see these vectors? No, you can't. So Apple had a recent update.
Excellent company.
Had a recent update which messed up the world over the weekend. Okay, like we couldn't even do church because of stinking Apple. Well, we did, but we made it work. But
Apple messed up our internet.
I like Apple.
We didn't have internet for like 4 days.
yeah, kind of frustrating.
Has Apple made portable chargers? Because I feel like they should.
Yes, they made their chargers are terrible.
They need to make portable chargers.
Portable chargers?
Portable chargers.
Oh, yeah, they make those, but
Because
their
they-
chargers are terrible. They
if they
fall
made
apart.
portable chargers, they could hold like a lot of battery life in them.
Yeah. Okay, so look at vector V. Vector V. What is the direction of that, and what is the magnitude of that? Of vector V. It's going up. Direction, so like from a horizontal line, be like maybe 90 degrees. Okay, and what about the magnitude?
Would it be 4?
Yep, 4 units.
Oh, cool.
All right.
Get roasted.
So just like with everything else, you can add vectors. So if you added, what happens? What would you think would happen if you added vector V with vector T? What do you think would happen? Where would you end up? Whole nother? Did you say whole nother? So do you realize when you say a whole nother, you're taking the word another and you're putting the word whole in the middle of it. That's not English, okay? But you and half of our country, 3/4 of our country, say this phrase, a whole nother.
I don't
I
say
thought it was a
I
whole
say-
other.
It is, that's the right way.
I say another.
Yeah, but it's another, but see what our country has come to. A whole nother.
It's the nether.
It's just weird. Another.
What?
I know. I'm not blaming you. You're just, see, this is the example of where like movies and popular
Mr. Flack, you
opinion
should be an
changes our
English teacher.
culture.
Yeah.
You should be an English teacher.
But this is so funny. Whenever people say this, my whole family looks at each other and just shakes their head.
Mr. Flack.
Snickers.
Mr. Flack.
A whole other
Oh, another?
or another whole thing or whatever.
You sound
Anyway.
like Mrs. Rumble.
What?
You sound like Mrs. Rumble. Just that when you did.
Well, I'll take that as a compliment because I am passionate about some of this stuff. Okay? People should get fined for saying this. I'm sorry, Jilly.
I disagree.
A whole nother.
And hi.
Okay, so what happens, guys, if you go up 4 and then down 4, where do you end up? Same place. So we're going to talk about adding vectors a little bit later, but these are just, so what's the terminal point? What's the terminal point of vector T? T is in Tom. What's the terminal point? D. Right. What's the initial point? C. What's the terminal point of vector W?
G.
Yep.
I thought it was
So-
W.
It is. I just said W because like George W.
Oh.
So any questions with that? You guys feel all right about that? Okay. So I'm going to stop sharing so I'm big again. All right. Next. So the magnitude of the vector is the length of the vector. Since magnitude is a length, absolute value bars are used to represent the magnitude of a vector. Okay. So if I wanted to say the magnitude of a vector, like vector V, what did it? It had like 4 units. So we'd say 4 units. Okay. So that absolute value is basically how far from the initial point we traveled.
Is there
Okay.
someone on the call?
Toby is. Yeah.
Ah.
Okay, so it's kind of like absolute value on a number line. How far from 0 is -3? Well, it's 3 units. Okay. All right. Any questions so far? So what happens if I wanted to find the magnitude of this guy here? So if I had So see this vector here? I want to find the magnitude of vector v. How do I find the magnitude of vector v?
Magnitude. No, it's magnitude.
I'm going to say w because that's confusing with that. How do I find the magnitude of vector w?
Wait. Did you
Yeah.
count up?
Rise over run would give you the slope. That would give you direction.
Count up units
Okay, so that's, what is that? Up 4 units
over 2.
and over 2. So if I wanted to find the terminal point of this would be what? 2 comma 4, right? Okay, so I could use the distance formula. So 2 minus 0 parentheses squared plus 4 minus 0 parentheses squared. Or in other words, square root of 4 plus 16, which is the square root of 20, which is 2 radical 5 units. Okay, so all I did, you could just use the Pythagorean theorem too. Just draw a triangle. Draw a triangle. Just count the units to see how far the sides are, right? And then use the Pythagorean theorem. 2 squared plus 4 squared equals c squared, right? That works. So that's finding the magnitude. Okay. Still doing all right? Are we good?
Yep.
Okay, so now we're going to talk about a specific type of vector called the component vector. The component form of a vector, component form, not the specific type of a vector, but basically we're going to tell you, basically it kind of tells you the direction and the magnitude at the same time, okay? So the component form of a vector lists its horizontal and vertical change. Vertical change in units. Okay? So, for example, over here, we went over 2 and then up 4. So instead of parentheses like we use like with a coordinate on a coordinate plane, we use these little less than and greater than signs.
Hurts my head.
Okay, so see how it's just like the terminal, it's really the terminal point. If this vector, if the initial point of the vector was at 0, 0, the terminal point would be that component form. Okay, so that means right 2, up 4. So right 2, up 4. Now, a vector isn't always at the origin, right? But you can calculate usually how far over and how far up it goes. Yes.
I was just going to say that this is a sad class environment.
Okay, so the magnitude will always be, the magnitude of the vector will always be that component plus that component squared plus that component squared, all square rooted, right? But that's just kind of a side note. We don't need to throw that in there. Okay. So, any idea any guesses what this is? Opposite vectors?
Would it be like negative numbers?
Could be, yeah.
Is that incorrect?
If I put that, shared the screen again, can you give me an example of some opposite vectors?
Or would it be?
Yeah, so because they're going opposite directions. That's it. Now magnitude, they have to have opposite like what Tristan said, that they both have a magnitude. It's not opposite magnitudes, but they have to have the same magnitude, right? So 4 and not -4 because magnitude is always positive, but they go in the opposite directions. Okay. All right. So opposite vectors with opposite components. So basically, opposite vectors have opposite components. So for example, 2, 4 is opposite -2, -4. Oops. So if I were to graph these, 2, 4 would be like this. -2, -4 would be like that, even though I kind of wrote it wrong, but does that make sense? So you just negate the X and Y value, okay, or the horizontal and vertical value. Okay, next we're going to add back vectors. That's easy. You just add the horizontal values and you add the vertical values. That's it. Okay, so it's hard to do this without. Okay, let's just. It's hard not to. I'm just going to share my screen. Forget it. I'm sharing my screen. So next, I'm going to add these two vectors. So let's write the component in component form. How do you write vector R in component form? How far left or right does R go?
0.
0. And how far up or down does R go?
4.
4. So, but it goes down. So how do you say down 4?
-4.
Okay, now look at T. Jilly?
You're
Yeah.
looking at the your lowercase.
We're looking at, okay, the lowercase.
Now we're
t
looking at the lowercase.
Yeah,
goes
yeah.
over 0.
Yeah, so vector T, it's going over 0, and then what's the vertical value?
-6.
Yeah, 6.
-6.
-6, so it goes
Oh,
down
it's way down.
6, okay? So now when I add these together, I get 0 plus 0 is 0, -4 plus -6 is -10, because that makes sense. If you go travel south 4 units, travel south 6 more units, you've traveled south 10 units, right? So far, so good? All right, let's try to complicate this, but we're not going to have much luck here. Okay, look at the next example. Let's add these. So how do you write U in component form?
U is going up 1, 2, 3, 4, 5.
Yeah, but why are you telling me how far it goes up?
Over 3. Over 3.
Over 3 first, and then up 5. Good. All right, what about J, Jilly?
Over 3.
Okay.
Hey,
I swear.
or not J, so vector B is next, right?
It's also going up. So it's going over 3. Yeah. No, 4.
Over 3.
I don't. What?
It's just the same. Over 3, down -5.
So vectors have direction and magnitude. So which direction is it going?
Down. So it's over -3.
So -3, so left 3,
Yeah.
and
And
then,
then down -5.
right, good.
Boom.
So now what happens when you add these together? What happens when you add these together? That's right, you get this
Oh,
vector.
dang.
Okay, so these are opposite vectors, which makes sense. When you add opposite vectors, they cancel out. Just like when you add opposite numbers, 5 and -5, they cancel out. Okay, any questions so far?
No. Seems pretty easy.
All right. So equal vectors are vectors that have the same magnitude and direction. An easy way to add equal vectors is to just multiply them by 2, right? I'm not even going to write that down. There is, this is known as a scalar multiplication of a vector. Okay, so if you want to triple a vector's direction and or not direction, but a magnitude, because we don't care about direction when we're talking about scaling. So you just multiply it, no problem. This is how these are written, okay? So when I want to look at example 4, let's look at example 4. I want to add these 3 vectors. Well, these are equal vectors, right? So what's the component form of vector A?
It's over going over 3 and up 3.
Over 2.
No, what?
Yes.
It's
Over
going over
2.
2 up 3.
Yeah, over 2 up 3.
When I
Okay.
stop repeating what I'm saying.
You didn't
So
say
now we're adding 3 of those. So let's just distribute. So what do we get? What's our resultant vector? 6,
6,
comma 9.
Oh my gosh.
Boom.
Okay.
Let's go.
Does that make sense?
Yes.
Okay, good. All right, next. Application real world. Okay, next chapter. Here we go. Lesson 64. Hey.
Yeah.
So next we're going to talk about angles interior to circles. Okay. All right, so let's draw a circle. Not the best, but oh well. A segment or arc is said to subtend an angle. So if I have a triangle in there, okay, and we'll call it E, D, E, F. So a segment or arc is said to subtend an angle if the endpoints of the segments or arc lie on the sides of the angle. In the diagram, angle EDF is subtended by arc EF or line segment EF. Okay? So we would say angle EDF or FDE is subtended. So write that word down, subtended by arc EF or line segment EF. Okay, so basically it's the line segment or arc opposite of the angle. Okay, so remember when we say measure of angle D, measure of angle EDF equals 1/2 of the measure of arc EF, right? You guys know that because this is an inscribed angle. So this was on one of your tests. So it's always going to be half of the arc that it intersects. So we don't really have any information on that line segment, but as far as arcs are considered, that's what that. So that subtends that.
Don't we already know how to do that?
Yes, but now there's a different type of subtension or subtend. Okay, so in another circle, let's draw another circle. Let's say that it's not an inscribed angle. Let's say that it is a tangent line intersected by a line in the circle. So this doesn't even go through. This doesn't even go through the center. It doesn't have to. So in this diagram, I'm just recreating the diagram in the book here. So I just need that there just to reference that arc. Okay, so far, are you seeing what are you guys doing?
What?
You guys are goofy. Goofy. All right. So here's the deal. The measure of an angle formed by a tangent of a chord. This is actually Theorem 64-4. The measure of an angle formed by a tangent and a chord is equal to half the measure of the arc it subtends or intersects, is equal to 1/2 the measure of the subtending arc. Okay, so if I wrote this with letters using this diagram, so the measure of angle ABC is equal to 1/2 what arc? What arc is this half of?
It is half of ABD.
So the arc ABD doesn't exist. So the arc has to consist of 2 or 3 letters on the circle. What? So A is not on the circle.
Oh, okay, ECB.
So ECB is this arc here.
Yes.
But this is the angle we're talking about. So what arc does this angle intersect?
Is it just CB?
Yeah, but we would have to say, because CB is this. So we have to say CEB or BEC. So remember, like whenever you have 2 points on a circle, there are 2 arcs. One going the short way and one going the long way. So if it's going the long way, you need 3 letters. So you need arc BEC. Okay, now it's hard to see that because it doesn't feel like it's intersecting. Well, it doesn't. This side doesn't intersect it, but this side is connected to that vertex, so it makes sense. So if this is like an inscribed angle without one leg or one side of the angle. Okay, so it makes sense that this angle would still be equal to half of that arc that it intersects, or we call it subtend. Okay. So let's look at some examples again. Okay, ready? So I want to find the measure of angle ABC. What is the measure of angle ABC? Can you see it?
The angle.
Yes, question?
Is AD 180?
Yeah, this is what's kind of lame about this example, isn't it? Very poor illustration.
Or is
We can only assume that it goes from A to all the way to B, so ADB. Okay, so this is going to be 1/2 of that arc, right? ADB.
actually it's a little more. It's like 8 degrees more than 1/2.
It looks like, no, it's not 1/2.
Or
It's half, that measure, that angle is going to be half of that ADB. right?
Right.
Because that's the arc that it intersects.
Right.
So what's the measure of ADB? What's the measure of arc ADB? The only number up there.
188.
188. Okay, so half of that is going to be what? 99
I don't know, I can't do that.
or 94. Okay, 94 degrees. So does that make sense? So it's just cut it in half. It's just like an inscribed angle. You just cut it in half. All right, what about B? Let's find the measure of PR. Okay, not the big PR, the small PR, right?
Is the angle 30 degrees? PRS?
Yes, that angle PRS is 30 degrees. So I want to find the arc PR.
It's half of 30. Correct? Or wrong?
Opposite direction.
Oh.
So it's
So if I write out the theorem would say measure of angle PRS is equal to 1/2 the measure of arc PR. Okay, so what we do know is this is 30 degrees.
so what you're saying is it's 60.
Yeah, so it has to be 60. So measure of PR has to equal 60 degrees. Which kind of makes sense. If you look at it, that looks about 1/6 away around the circle because there's 360 degrees. So 60 out of 360 is 1/6. So it makes sense. But you can't always go with your gut in this textbook because they're not always perfect with their drawings. Okay, so far so good. Does this make sense? What if I did ask for the big arc? What if I did ask for this big arc? Let's say there's a Q over here. What's the measure of PQR?
Wait,
Half of 30?
Nope.
knowing that there is 60 there?
Yeah, there's 60.
60 minus 360.
Right, so this would be 300 degrees. So we don't, and you could do it the other way, Jilly. If this was 30-degree angle, that means this angle here would be what, 150 degrees, right?
Yeah.
So, and this is half of the arc, so that arc would have to be 300 degrees. Make sense? So you could do that both ways. All right, next. Theorem 64-2. Here's what Theorem 64-2 says. Now this is interesting. So if I did two chords, and these chords are not these are not diameters. I mean, they could be, but they're not. They're just random. They cut this. This is like somebody who's really hungry and doesn't take the time to cut the pizza the right way, right? So that's what happened.
Actually,
Okay.
I did cut people like that one.
So here's what the theorem says. If these are angle 1 and 2, and this is A, B, C, D. Now, if this was right in the middle, guys, if this was right in the middle, then it would be just the central angle would be the measure of that arc, right? If it was right in the middle, and if it was all the way to the side, it would be half. So if it kind of shifts a little bit like that, you know what happens is instead of the central angle, that central angle, this angle is getting bigger and this one's getting smaller. So basically it's the average of these two arcs that will give you those angles, okay? So here's the deal. Here's what Theorem 64-2 says. The measure of an angle formed by two chords intersecting in a circle is equal to half the sum of the intersected arcs, or the average of those arcs. Okay, yes.
On your screen, it looks, your stuff looks purple. Why is that?
It does.
What's purple? I don't see purple.
Well, from here, your marker looks purple.
Oh, I don't see it. So the measure of an angle formed by two chords of a circle is equal to half the sum of its intersecting arcs. Intersected arcs. So if I wanted to use this diagram, I would say this. Angle 1, measure of angle 1 equals measure of AD plus measure of BC divided by 2. So this is just the average of these two arcs. So if this was 60 and this was 100, what would be the measure of angle 1? So if AD was 60 and this was 100, how do you find the average of two numbers?
You add them and divide them.
Yeah, so what's 160 divided by 2 is 80.
Yeah.
Basically, the average of two numbers, the easier way to do it, if you can, is just halfway between the two numbers, which makes sense because you're getting closer to this side and farther away from this side. So this angle is going to be the average of those two. So if this is 60 and this is 100, halfway between 60 and 100 is 80. Okay? So what would the measure of angle 2 be?
All the other numbers added.
So this angle here, which is the same as that angle, it's the average of these two arcs.
Yeah.
Okay, so measure of arc AB plus measure of arc DC, all divided by 2. Okay? All right, so let's do some examples. Or who thinks they're playing it? Okay, ready for an example? Here we go. Okay, can you find X? Let's find X.
Well,
What example is this?
what you need to do all
Pentillion.
three of those angles. So, T, Q, R, R, S, right?
No, you just need two arcs.
Which two do you decide to use?
Well, what arcs is angle X
Oh.
intersecting?
Q, QR and RS. No,
No,
no, no, no,
QR
no.
and
Q,
ST.
R, and, yeah,
Basically, the only measures they give you.
yeah.
So now if we wanted to find these, we'd need to know these arcs, which we don't know.
So
But-
just divide that by 2,
No, it's them
or you
added.
add them and then divide them by 2.
Yeah.
Mhm. So you can figure out what's happening. It's going to be a decimal or a fraction, which is a bummer, but whatever.
That's
What's halfway between 70 and 195?
125.
Is it?
No,
No.
155.
So let's see, that's 125 away. So half of that is 62.5.
I was so close.
So X equals basically 70 plus 195 divided by 2, or halfway between 70 and 195 is 70 plus 62.5, 132.5 degrees, I think. Let's see if we're right.
132.5. Boom.
Yes.
132.5. Boom.
Okay, does that make sense? You just find the average. Use your calculator. If it's not something simple like 60 and 100, well, halfway between that is 80, then just add them up and divide by 2. Yes.
In younger math, why don't you let it, like in 7-8, you didn't let us use a calculator. Why?
That's right.
You gotta learn.
Because you would have been a lot dumber if I let you use a calculator. So then you don't know your you don't have to remember what 7 times 6 is. What's 7 times 6?
36.
No.
The world of YouTube heard you say that. That was Maddie. That wasn't Jilly.
What the heck? That's what it was to me.
Wait, it's 42, right?
Yes. Okay. Your life is easier because of that.
That's 6.
That's so fast too.
Hey, it was 1/6 off.
1/6 off. I'm not even gonna respond to that. Okay, that's all I got. Good job. We are done.